Hello everyone, my name is Swapnil Kulkarni. I am from Automation and Engineering. Today we are going to discuss about one of the application SolidWorks plugin we have developed for sheet metal industry. This plugin is called SM Utilities. A typical process for fabricator is that we have to generate parts in or design parts in SolidWorks, or we get data from other software and then import that into SolidWorks and then process that into two different formats. One is for laser cutting, one is for bending. Now in this process what happens is that a designer has to spend time importing the data in a format of like step or a parasolid, something like that, and then after importing the data one has to categorize that into two different categories. One is sheet metal component, one is non-sheet metal component. Once you identify that some of the components or some of the geometry is sheet metal and some of the geometry is non-sheet metal, after that you concentrate on the components which are sheet metal component, then you convert those into SolidWorks sheet metal format. Once those are converted into SolidWorks sheet metal format, the process begins of creating a drawing and creating a DXF for laser cutting. Now in this process, even before creating the drawings, one need to know all the sheet metal parameters. For example, what is going to be the number of bends in a component, what are bend radius, bend distances, then thickness of the material, so on and so forth. SolidWorks API allows you to capture all this data and put it into a whichever format you want. For example, in our application, we put that data into an Excel sheet. Once a part is converted to sheet metal, that is, now you can flatten the part. This next step is basically to create a drawing. Now, while creating a drawing, a conventional method to do this is basically placing the views and then adding the dimensions. Now, while placing the views, one has to place orthogonal views, isometric view, and a flat pattern. And then after that, you put some data in a tabular format. For example, all the sheet metal parameters in a table which is called a sheet metal cut list, and probably either a bend table or you add dimensions into the orthogonal views wherein the operator on the shop floor can understand that. Once you do that, you also have to export the flat pattern as at 1:1 scale, which in a DXF or DWG format, which can be then given for laser cutting. You also have to export a bill of material which actually shows you how many components are there, which are sheet metal component, which are non-sheet metal component, and all the parameters which belongs to these components. If it is a sheet metal component, what are the parameters which you want to export? The format can be decided, but the typical data would be thickness of the sheet, bounding box area, blank area, number of bends. If you require for every bend, what are the bend parameters like bend distance, bend angle, bend radius, these parameters, and the direction. Now this is a conventional way of doing things. What we have done in this SM utilities is this entire process which I have just explained, which we are doing it manually today, is entirely automated. What one has to do is when you start the plugin, you just have to browse to a folder where you have kept the data which is to be imported, and entire process will be automated for you, wherein I'll just explain how it works. There are two buttons which are given. One is import and convert, second is drawing and bomb. Now import and convert, what it does is basically when you browse to a folder, it will import all the step files in that folder. It will categorize based on the topology whether it is a sheet metal component or not, and then those components which are sheet metal components will be converted to sheet metal, SolidWorks sheet metal automatically. Once that part is done, okay, all the data will be saved and one report will be exported in an Excel format. Now this report will show you as to how many components are imported, how many components are successfully converted to sheet metal, how many components may not be converted to sheet metal successfully, because sometimes you need to do some tweaking in the geometry, because some other software, the way they create the geometry, it may not be exactly be flattenable inside SolidWorks. So you might have to add certain corner reliefs, or maybe add excuse me, maybe have to add gaps, and then you can flatten them. So this report will help you. This report will also have hyperlinks created, so that you can go through the report, open only those parts which are failed, and then you can work on them manually. Once all your data is ready to go for drawing process, you can open the assembly or a part file, and then hit on the button which is called drawing and bomb. Now what does this particular button does is, basically it will create, if you have selected an assembly, then it will create drawing for every component in this assembly. If you have created a if you have selected a part, it will create a drawing for that part. Now when you select an assembly, okay, every component will be opened up. We take a picture of the component which is used for bill of material. We insert a thumbnail of this picture, I mean component. Then it creates a flat pattern. It will start a drawing. It will calculate bend distances, okay. Even though the data is imported, it doesn't matter. It calculates the distances from the geometry and not from sheet metal or SolidWorks features. Then it creates places the views. Isometric view is placed, one flat pattern is placed. Now the flat pattern will be scaled up automatically to use the maximum area of the drawing sheet. It will generate the flat pattern view and then insert the bend distances. Okay, there are two options available. One, you can directly insert the bend distance on the flat pattern, or you can generate a bend table where it will, for every bend, it will show you what is the bend distance. Both the options are available. And then it will generate a bill of material. Okay, now this bill of material will have, of course you can control the data which you want to export into the bill of material, but typical data what is exported is all the sheet metal parameters and a thumbnail. Now the thumbnail for sheet metal components are going to be two, one a flat pattern and another will be an isometric view. Okay, let's go to SolidWorks and see how the plugin works. Okay, now I have SolidWorks which is occupying half of my screen, and I have Explorer, File Explorer, which is occupying half of the screen. I'm going to start the first process of importing the data. So you import. Now this UI, okay, you can select what kind of data you want to import, and then you can simply copy the path, paste it here. You can apply a K factor. We can apply K factor. We can also allow you to have a bend allowance or whatever you want. So you can apply that. Of course we cannot change, I mean we can have a table which we can discuss later. We can apply material, okay, and then there is also this button here which helps you identify the component's fixed face. Okay, this will help you later. I'll show you how it helps, and then you just simply have to click on the submit button. Now you can see that the part is imported. It shows a message, and then in the file explorer you can see the part is created. An Excel file is also created. So this is the Excel file which is generated right now. Now it shows that this component has been imported. Import is successful. Thickness is 1.2. Material what we have applied, K factor what we have applied, and convert to sheet metal is also successful. This is very important. You can click on this hyperlink to open the part. So now the part is open here. So now you can see the geometry is imported, then it is converted to sheet metal, and you can see the face which is a fixed face, okay, is marked in red color. Okay, So the next process is basically to run drawing and BOM. So if I click on drawing and BOM, okay, it will take the active document. You can select the templates. There is a list of templates. You can choose your own templates, and then you just have to click on submit again, and then it will start calculating the bend distances, and also start creating a drawing. All the templates which I have selected here, okay, can be customized further by you. Whatever data you want which is available in SolidWorks or something which we have calculated can be inserted in these tables. Now you can see that the flat pattern view is vertical right now. Later on it will be rotated automatically depending on the orientation of the component or the flat pattern bounding box. And one isometric view, a table. Excel files are generated automatically, right? So let me open up the drawing. Now this drawing here, okay, is completely created automatically. You can see the drawing here. These are the fixed phase distances, okay, and then you can see that this is the first bend, this is the third bend. All these arrows what you see are basically the distance from where the bend distances are measured, okay. Now this table over here shows you that what is the material, thickness, cutting length outer, cutting length inner, number of cutouts, okay. Then bends, bending, bounding box, width, length, bounding box area, weight. This is a bend table where for every bend, direction, angle, inner radius, bend distance, and bend line length. Now bend line length is required because on a press brake, when you want to set your tools, the punches basically, you need this length. That is why we calculate that. So all this drawing what you see right now is completely created automatically without any manual intervention. Okay, then let me go to the folder where we have created this data. So this is a drawing, this is another Excel file, and this is a folder because the thickness of the component was 1.2, so it has created a folder, and in that folder it has created this DXF and SAT files. Now these what we basically do is that this data, okay, is segregated based on thickness and material. So if you have an assembly, okay, which has multiple components with multiple material and thicknesses, okay, then all that is created and pushed into folders depending on what the material and what the thickness of the material is, okay. This is the DXF file which is created. Now let me show you the bill of material which we have generated. Now in this is the bill of material which is generated. If you look at the bill of material, it shows you part number, unfold, what is the file which is DXF. So these are all hyperlinked, so you can open them directly by clicking here. Material quantity, then number of bends, total cutting length, number of pierces. All that information which is typically required for a sheet metal manufacturer is given here. Then a thumbnail sheet is there where you can see that this is the component which was imported. This is a flat pattern view, this is the isometric view, and sheet 3 contains all the information about the bend. Okay, so how many number of bends are there, basically the bend table which we had in the drawing. Okay, so all this information, all the drawings, everything is created automatically using this utility. So thank you all for your time. This is what this particular utility does. If you have any doubts, any clarification required, or any more information required on this front, please contact me on market marketing@anyindia.com, or you can call me on this number. Thank you.